Hello students, in this video we'll see an example of how to solve an exact differential equation. Let's recall an exact ODE has the form m of xy dx plus n of xy dy equals 0, with the condition that partial m partial y equals partial n partial x. This is a condition we must check for exact equations. Once this exactness condition is checked, this implies that there is a function f of xy such that two things are true, such that partial f partial x equals m, partial f partial y equals n, and the solution to the equation is f of xy equals c. Once we find this function f, we're done with the problem. Let's consider the following example. Let's consider 3x squared plus cosine y plus y dx plus 1 minus sine y times x dy equals 0. So now we check to see if our exactness condition is verified. So this expression over here is my m. This expression over here is my n. So partial m partial y will be 1. The derivative of cosine is negative sine, so negative sine y. Partial n partial x will just be 1 minus sine y. And since these expressions are equal, we see that the equation is exact. Now I can see that there must be a function f. We can try to find f such that partial f partial x is equal to m, which is 3x squared plus cosine y plus y. And partial f partial y will be n, and n is x minus x sine y. So now we will partially integrate the first equation with respect to x. So we'll do a partial integral, which will tell me that f of xy, integrating with respect to x, will be x cubed plus x cosine y plus xy plus a constant c, which now depends on y, since partially integrating with respect to x treats y as a constant. So I'll have c of y. The c of y is unknown, which means that we'll need to use the second condition to verify. So this condition over here tells me that partial f partial y is equal to x minus x sine y. I can also compute partial f partial y from this equation. Partial f partial y will be negative x sine y, and then I'll have a plus x. Since these two expressions agree, I see that we can choose c of y plus c prime of y. This c prime of y term can be chosen to be 0, which means that c of y is a constant which we can choose. So we can now update our function f of x is x cubed plus x cosine y plus xy. I'll choose my constant c just to be 0, and the solution to the equation is found by setting this function f of xy equal to c. And so now we have the level sets of this function being the solutions of my exact ODE. Thank you very much.